Hello everyone, welcome to the analysis of the QA section of mock number 19. Now we'll start with the first question. Now looking at this question, it seems to be having a lot of information, okay? And once you read, you will not feel so confident about this question. But when you will start looking at the small things that are given in this question and try to connect the dots, then you will be able to understand the logic behind solving this question. Okay. Now, I will consider a few things like this. So common ratio R is given as 1 upon n, where n is a natural number. Now, n being a natural number, R is equal to 1 upon n. So I can say that the value of R will always be positive. Okay. So if the value of R is positive and one of the terms, the third term is given as 2000. So third term is positive and the common ratio is also always positive. Then I can say that every term of this geometric progression will be a positive number. Okay. It will be a natural number or not. I'm not bothered about that, but it is important that every term will be positive for this geometric progression. This particular thing will be useful in this question because there are some inequalities which are given in this question. Okay, so let's begin solving this. Now, third term T3 is given as 2000. Okay, now the first inequality I'll pick is P7 is greater than P6. Now, what is PK? PK is the product of first K terms. All right. So that means the product of first 7 terms is greater than the product of first 6 terms. This is the first inequality. Now, the product of 7 terms can be written as the seventh term multiplied by the product of 6 terms, and it will be greater than product of 6 terms. Now, since all the terms are positive, the product of these terms will also be positive. So P6 will be a positive number. So if I cancel out P6 on the both sides of this inequality, then the sign of inequality will not change. So from here, I can say that T7 will be greater than 1. All right. Now T7, it is seventh term. It can be written as the third term multiplied by R raised to the power 4. So the third term when multiplied by R 4 times, I'll get the seventh term and it is greater than 1. The third term is given as 2000. So why I have written T7 as T3 into R raised to the power 4? Because T3 is given to us. So from here I can say that R raised to the power 4 will be greater than 1 upon T3, that is 1 upon 2000. Now R is given as 1 upon n. So 1 upon n raised to the power 4 is greater than 1 upon 2000. Doing cross multiplication, it can be easily done. 2000 is positive, n is also positive because n is a natural number. So I can say that n raised to the power 4 will be less than 2000. Now, what will be the values of n for which n raised to the power 4 will be less than 2000? Okay, so if I'll take n equal to 6, so n equal to 5, it is clear. N equal to 5, 5 raised to the power 4 is 625. 6 raised to the power 4 is 1276. 7 raised to the power 4 is 2401, which is greater than 2000. So I can say that the value of n has to be less than 7. n का value 7 से छोटा होना चाहिए, so that means it can be any number up till 6. So it can be 1 2 3 4 5 or 6 because n is a natural number. Now in the similar manner I will take the second inequality which says P7 is greater than P8. Okay, so P7 as it is, which is greater than P8 multiplied by P7. Now P7 can be cancelled out from both sides without changing the sign of inequality. So I can write that T8 is less than 1. Once again, T8 can be written as T3 multiplied by R raised to the power 5, which is less than 1. So T3 being 2000, I can say that R raised to the power 5 is less than 1 upon 2000. Okay, and from here I will get n raised to the power 5, n raised to the power 5 to be greater than 2000. Okay, so what will be the value of n for which n raised to the power 5 will be greater than 2000? So it will happen when n equal to 5, does it? So n equal to 5, it it will be greater than 3000. N equal to 6, greater than obviously 2000. Okay, so but I check for n equal to 4. So 4 raised to the power 5 is 1024. Okay, 1024. 4 raised to the power 5. So it will not be possible. So I can say that n will be greater than 5. This is the second range of n. So n has to be greater than, n should be greater than 4 because 5 is included. So n has to be greater than 4. All right. Now n is greater than 4 and n is less than 7. So what will be the possible values that n can take such that n is a natural number? So n can be 5 or it can be 6. So there are two values of n which will satisfy the given conditions. But we need to find out the maximum possible value of n. So the maximum possible value of n among these two values will be equal to 6, and 6 will be the correct answer for this question. So that is question number 1. After knowing the solution, it seems to be a very easy question, but it is actually not. I would keep this question in a category of slightly above moderate level of difficulty.